Hello, and welcome back to another project data science tutorial video. So my name is Steven, and this is the 80/20 Pandas project data science tutorial. So in this video, we're basically going to be looking at the 20% of pandas that you can learn right now that's going to give you 80% of the value. So this is related to something known as the Pareto principle. But basically, with pandas, there are a small number of features and functions and objects that you're going to need to know most of the time. And then there are a lot of things that you're very rarely going to use, or you're only going to use every now and then. So this video is designed to show you that small number of things that you can use most of the time. So if you're looking for a very quick way to get up and running with the Pandas Python package for data science, then this video is for you. So let's go ahead and dive in. By the way, quick note: there's a link in the description below with a blog post that you can follow along with if you want, or you can just watch this video here. So first things first, we're going to be using our local professional data science environment here. So if you don't have that set up, click the link in the description and you can get this environment set up. So the things that we're going to be using are the terminal. We're going to be using Python, obviously, a Python virtual environment. We're going to be using Jupyter notebooks. So you can get all those things installed with that link in the description to get your data science environment installed. But first things first, I'm going to open up a terminal here. Let's get a new terminal, drag it over here. All right, so I am going to, let's change into my project data science directory here. I'm going to make a new directory. Well, let's look at what we've got. So I'm going to make a new directory. I'm going to call it 80/20 pandas. And I'm going to go into that directory. There we go. Now I'm going to activate a, let's see, which environment do I want here? So I'm going to activate this updated sklearn environment. I think this should have everything that we need. My base installation, actually, my base Python virtual environment probably has what we need as well. But, just to check, let me check that I've got pandas installed. So import pandas. And if this, all right, that worked just fine. So I was basically just checking really quickly that we have the pandas package installed in this notebook here, or sorry, in this virtual environment. Let's take a look at which Jupyter notebooks we're using. All right, so I'm going to go ahead and launch Jupyter notebooks in my terminal, and I'm going to throw this ampersand here after the command to run Jupyter notebooks in the background. So I go ahead and do that, and let's see if Jupyter notebooks pops open. It does over here on this window, so let me drag it over. All right, there we go. So you'll see that we're now running our Jupyter notebook server in this terminal. It's running in the background, and here we go. Here is our notebook dashboard. So I'm going to go ahead and create a new Jupyter notebook. And by the way, this Jupyter notebook is basically just where we're going to be doing our pandas work. It's just a nice, convenient way to kind of see what we're doing and have a document that shows us all the pandas work that we're doing here. So I'll call this 80/20 pandas and save it. And we're ready to go here. So obviously the first thing we need to do is import pandas. So I'm going to go ahead and do that. I'm going to import pandas as PD. This as PD here, this is just the convention that the pandas developers decided to use, or the Python data science community decided to use. So this is just how everyone typically imports pandas. They alias it as PD. So from here on out, we can do things like, PD dot whatever, and we can call our objects from here, like our DataFrame, or our methods like read CSV, etc. So really quick, what is pandas? So you can think about pandas as being kind of like Excel for Python, sort of. So the basic way that we're looking at data with pandas is exactly like you might think of an Excel sheet, right? So in Excel, if you have data, you've got rows of data and you've got columns of data. So and that's basically how we're going to represent data in pandas as well. So one of the first things that we want to do when we're looking at a new Python package like pandas is we want to ask that question, what's the primary functionality here? With pandas, primary functionality is working with data in a similar tabular method like you would do in Excel. We also want to ask, what are the primary objects and functions and classes inside of our package? And with pandas, we kind of have two primary objects that we're working with here. So the first one is the pandas series. So actually, I'll go ahead and let's see. What are our primary pandas objects? And we've got two. We have a series and we have a data frame. All right. So what is a series? So pd.series, let me throw this handy dandy question mark after it there, and this will pull up the documentation in Jupyter Notebooks. So pd.series, so here's the signature, but let's look at the doc string really quickly. So a panda series is a one-dimensional in-D array. So this is a NumPy in-dimensional array. So basically a multi-dimensional array. You know, and the way that you can think about that is just kind of like, think about a Python list as like a one-dimensional array, and think about like a list of lists as a two-dimensional array. That's kind of what it is there. But you know, if you need help with the NumPy side of things, we also have some tutorials for that, so you can learn NumPy as well. So it's a one-dimensional array with axis labels. So thinking about this in terms of Excel, this would just be pretty much a column, right? So if you have a column of data in an Excel file, you're typically going to have a name for that column. You know, that name might be a person's first name or the name of a country or something like that. And then you'll have data in that column. And that's basically exactly what we have here as well. So we have a series name or a label, and then we have the data values there. So let's go ahead and let's close out this documentation. Let's create just kind of a basic series here. So let's say that we want to create a series of colors. So I'm going to say we have blue, we have red, we have green, and I'm going to name this series color. So this is kind of like our column name here. So we run this, and here you go. This is basically what a Pandas series looks like whenever it gets printed out. So here are our values. So we have the value blue, we have the value red, we have the value green. This over here on the left is our index. So you can do all kinds of interesting things with your index inside of Pandas. But fundamentally, an index is just a way to label a specific row. So here, this row has the index 0, for example. And then here, the index value is 1. Here, the index value is 2. So it's basically just a way of like labeling your rows. And then you see that the name of this series is colors. Now let's take a look at this D-type object really quickly. So remember that, let's see if we go back to the documentation. Do we have any information here about it? About it. There's something I want to, all right, so D-type here. So the data type for the output series, if not specified, this will be inferred from the data. So this is a little thing about NumPy as well, but essentially our series is going to have the same data type. All of the data in that series is going to have the same data type. And if you pass in values with different data types, like let's say you've got some strings and you've got some integers and you've got some float values and you've got some Boolean values, then Pandas is going to find the kind of the least common denominator data type that it can cast all of the data to. So in that case, if you have mixed data types, typically the least common denominator is going to be a string, which this data type here will reference as object. And the reason why it can only be one data type has to do with the NumPy array, which is at the heart of the Pandas series. But you don't have to think about that too much. Just know that this Pandas series here is going to have a singular data type. It's just going to have one data type. So if a series is like an Excel column, then a data frame, which is the second primary Pandas object here, is basically going to be the whole spreadsheet. And a data frame is just a collection of these series objects with a little bit extra stuff as well. But let's create a data frame here so you can see what's going on. We'll create just kind of another contrived data frame, just something simple so you can see what's happening. So let's create two series. So actually, I'll go ahead and copy this one down here. So we've got colors, and then let's create another one, which is maybe, like what's the first letter here of each of these colors, and we'll give this the name first letter. So we're creating two different series, so two different columns in a spreadsheet. Kind of think about it like that. So I'll go ahead and run this cell, and now basically what I'm going to do is I'm going to create a data frame using these two series. And I need to do this little transform thing here. Don't worry about that. We don't usually create data frames this way. So this is a little bit contrived, but I just want to kind of show you here. So we'll call our data frame df. If you run type df, you can see that this is a Pandas data frame object. And if we just look at it here, there you go. You see that basically what we're dealing with even kind of looks like a spreadsheet inside of Jupyter Notebooks. We've got our colors column, we have our first letter column. We can have as many rows as we want, we can have as many columns as we want, and this is a perfect representation of tabular data. And by getting the data into a Pandas data frame, we essentially enable ourselves to be able to do all kinds of analysis, data cleaning, data aggregation, data transformations. We're able to do all kinds of things with our data once we get it into a Pandas data frame. So we don't usually create data frames like this. We usually have actual data to work with. So let's go get some actual data. I'm going to look up the Kaggle happiness, this link right here. So the World Happiness Report. So it's at this link. I think it's user, UNSDSN, World Happiness. You can probably just find it via Google as well. So we go to this link here. If you don't have a Kaggle account, you might need to create one. Yep. All right. It wants me to sign in really quick. Okay, so I'm signed in, and now I can click this download button to get our data. So, it'll download here. I'll just go ahead and click on that. And there we go. So it came in as a zip file, but clicking on it in Chrome there went ahead and unzipped it for me. So I'll go ahead and delete this .zip. We can take a look at our archive here. So this has basically data files for 5 different years here. We're just going to use the year 2019. So I'm going to move it in my terminal here just to show you this in case you don't know how to do it. So we're going to here, let me drag this over so you can see what's going on. All right, so we're going to move MV from our home directory, from our downloads, then the archive directory, 2019.csv, and we're going to move it to this folder, which I'm just going to use the period for, because the period in the Linux shell means this folder. So we move that. You'll see that the file disappears over here. We can go ahead and delete the rest of that archive folder there. Close this out. Now, if I go back over, let's close this. In my Jupyter Notebook, actually, if I hop back into the notebook dashboard really quickly, you can see that there's my CSV file in the same directory as where I started the Jupyter notebook. So we now have a data file we can play with. So one of the most common ways that you'll probably find yourself loading data is using the pd.read, if I hit tab here. So we've got all kinds of read methods or read functions, but we're going to be using the read CSV function here because we have a CSV file. So let's just type in the file name here, 2019.csv. And there we go. So we've just loaded our data. Now let's take a look at this. Here we go. This is some real data to work with. So our data set is essentially a list of countries, more or less all the countries in the world. And we've got this happiness score here. And this happiness score is kind of an aggregation, I think, of a bunch of other information. We don't need to worry too much about what it is right now because we're just learning pandas. But we've got this other information about the country here. So, we could ask ourselves like which things are related to the happiness score, but we've got the GDP per capita. We have some measure of social support. We have some measure of a healthy life expectancy, freedom to make life choices. So all of these are defined using some kind of numeric scale that the people who created this data set use. We don't need to worry too much about that. So, basically what we have here is some data about countries and how happy they are and some other metrics as well. So whenever we're looking at Pandas DataFrame, we can print it out kind of just like this. And this actually shows us that we have 156 rows by 9 columns, which is good information to have. But if we just want to look at the top couple rows, which we often want to do, then we'll use the .head method on our data frame. And this will just print out the first 5 rows here. Now, if we want to look at the shape of our data frame, we can use the df.shape attribute. And this will show us, like we just saw a second ago, that we have 156 rows and 9 columns. Now, if we want to look at what our columns are, obviously we can see them just right here. But, we'll very often want to access our columns directly using the df.columns attribute. And here you see that here are all of our columns. And, one way that you might want to use this is to, you could filter your columns based on some kind of name, or you could get a list of all your columns and then rename them or something like that. So lots of different things that we might want to do there. And then going back to what we said before about each series having a certain data type, each column here is going to have a data type, and we can look at those data types using the I'm going to start typing D and then hit tab and come down here to the D types. There we go. And so what you'll see is that our overall rank column, which is a series, is an integer data type, which makes sense. The country or the the country or the region is an object, which is, basically a string. And then the rest of our columns here are floats, which makes sense looking at our data. Lots of floats here. So now we know the data types of each one of our columns, which is really helpful. And I'll go ahead and give you a pro tip related to data science and data cleaning specifically. This is a good way to just do a quick spot check on if you might have dirty data. So for example, if our healthy life expectancy column looks like it should all be floats, looks like it should be numeric, but we see that it's actually an object, well, that means that Pandas, when it was reading the data in, found a string or something that it couldn't convert to a float value, which meant that it had to go to the lowest common denominator data type of, let's say, a string. So if we were to see an object here, object data type, when we weren't expecting it, that might give us a clue that we have some dirty data. But that's just kind of a little extra tip here related to data science. So since we have a lot of numeric data, one of the next things that we might want to do is to look at some basic descriptive statistics of our data. So things like the mean of each column, the minimum value of each column, the maximum value of each column, things like that. The Pandas DataFrame object gives us a very handy method called the describe method. And we can call this on our data frame, and Pandas will return basically a list, or sorry, another data frame of some of our descriptive statistics. So we have the count. This is going to be basically your non-null row count for each one of these things. So you see that all of these are 156, which means that we have no missing data in any of our columns, which is good. You'll see that we have the mean here, we have the standard deviation, the minimum, we've got our quartiles and our maximum here. So I guess really quick, let's take a look. So our maximum happiness score looks to be right around 7.75, and our minimum is right around 2.8. So it looks like our happiness score has a range of about 2 to about 8, roughly. And where is the median? So the median is right around 5 here. So that's going to be kind of like right in the middle of where the countries fall. All right, and let's take a look at maybe one of these other columns, maybe some generosity here. So generosity looks like we have a minimum value of 0. That's not a very generous country. And a maximum value of 0.566. So this is kind of what I was saying earlier about these columns having some kind of metric that the people who created this data set have that maps, a generosity score to a value of like 0 to 0.6 or something like that. So we have our descriptive statistics. You'll notice that we do not have any kind of descriptive stats for our country or region column. And that's because that column is a string type, an object type. And the describe function, kind of with the default functionality here, only includes numeric data types. So if we want to see some descriptive statistics for the string data types as well, for kind of the objects, then we can just throw in this include equals all parameter. And there we go. We get our country column back in. So this actually, this doesn't give us that helpful of information because, the mean and the that stuff doesn't make sense, like the mean and the minimum and the 25% quartile. But we do have this frequency, which shows us kind of what the most common value is. And in this case, our most common value only shows up once, which means that each row kind of only shows up once. So this tells us that each country in our data set only shows up once. And there's another way that I personally use all the time, which is if we access this column here, this value counts method. So this is going to show us kind of the same thing. We're going to take a look at this column, and then we're going to get the number of rows for each unique value within that column. And it will sort the values from most common to least common. And in this case, these are all ones, which means that each value only shows up once. But we'll come back to this later. So here are our descriptive statistics. Okay, so far we've looked at some high-level characteristics or qualities about our data frame. But now let's say that we want to start getting a little more specific. We want to start looking at specific columns. So I did just show this to you, but now let's talk about it. To access a column in your data, you can just use square bracket notation, very much like you do with a Python dictionary. So I'm going to start typing the column name. I'll hit tab, And then Jupyter Notebooks does this nice tab complete for us with the column names. So if I run this, you'll see that we've extracted just the country or region series from our Pandas data frame. And actually, if we look at the type of this really quickly, you will see that this is, in fact, a Pandas series. So a data frame is a collection of series, and a series is basically just a column. So we can access those columns using this square bracket notation here. And if we want to access multiple columns, then rather than passing in just a single string, let's pass in a list of columns here. So I'm going to pass in country or region. I'm also going to pass in score. And now that you'll see that we're returning 2 columns, and since we're returning 2 columns, 2 series side by side, we're getting a data frame back, because remember, a data frame is a collection of it's a collection of one or more series. And so so we're getting that data frame back right there. Now let's say that we want to dig in more to our score column here. So first of all, I'm just going to take a look at the score column. You know, Pandas is going to show us kind of by default the first 5 values and the last 5 values, you know, because we have 156 values here. We could have thousands or millions. So Pandas doesn't want to print out all of those, so it just kind of prints a little selection. So you'll see that it looks like these are going down in value, but let's say that we want to look at this numeric data in a way that we might usually want to look at numeric data using a histogram. So plotting a histogram in Pandas is very easy. If you have a numeric column like this, a numeric series, all you have to do is call the .hist method on that series. And under the hood, Pandas is using matplotlib to plot our histogram, and there we go. So we can see the distribution of these happiness values. So you'll see that we have, you know, a few countries down here in kind of the 3 to 4 range. It looks like most of our countries are here right in the like 4.5 to 6 range. And then we have a few countries up here in the higher ranges as well, from like 6.5 to 7.5. So kind of that normal quasi bell curve, that normal distribution that we see all the time. So there are a lot of other methods on numeric series that you can use. And so I'll actually go ahead and just say score equals df score. Let's go ahead and just assign this series to a variable. And let's take a look using tab complete here at some of the methods that we have. So you'll see that we have other mathematical kind of aggregation methods on our series. So we have this ABS. Let's take a look at that. This is the absolute value of the series. We don't have any negative values, so we don't need to worry about that. But if we keep scrolling down, let's find some other ones here. We've got count and we've got covariance, and I'm going to go ahead and start typing M so we can find some of these: max, mean, median, min, mode. So we already saw the descriptive statistics using the .describe method on the data frame, but we can also use these methods right on the series itself. And so here, here we're kind of just doing these calculations on a single column in our data set. Now, one thing that you will probably want to do quite often is to sort your data by one of your columns. This is very much like you might do in Excel, right? Lots of similar functionality here. So let's say that we want to, let's take a look at our data frame. Let's say that we want to sort our data frame by this healthy life expectancy from the maximum to the minimum to see what our kind of healthiest countries are. So the way that we can do that is if we call the dot, and let's just start typing in SO, and then I'll hit tab, and you'll see that we've got two different options here: sort index, sort values. So the index is this thing over here on the left that I was telling you about earlier. We want to sort the values, and we want to sort the values by this healthy life expectancy. So I'm going to copy this column name right there. And so if we sort the values, you'll see that this prints it out here. And basically, this means that Pandas is sorting the data frame and then returning a new object and printing it out. So whenever you see an object printed out like this after calling a method, that means that we're returning a new object. So we're not doing this operation on the data frame itself. And down here I can show you that if we print out the data frame, that our original data is still unsorted by healthy life expectancy. And you can see that the index over here gives us that indication that it's sorted by the original order that we loaded it in. But after sorting the values here, you'll see that our index is kind of shuffled. And so our original data is still in this kind of original order. Now, if we want to have our data sorted by healthy life expectancy, then we can just assign this back to our object here, to our data frame object. So let's go ahead and just do that. And I'm going to pass in another parameter here, which is the ascending parameter. And I'm going to say ascending equals false. So you'll see that healthy life expectancy is currently sorted from 0 up to like 1.4 right now. I want to sort it the other way. I want to sort it kind of in descending order. So let's do that. And now, if we look at our data frame, you'll see that it is sorted by healthy life expectancy. And so it looks like Singapore and Hong Kong and Japan. So that's very interesting. Even though these countries are not the highest in the happiness score, they're down here actually kind of in the lower 6 and in the 5 range. They do have the highest healthy life expectancy. So that's pretty interesting. Now, I actually want to get us back to kind of our original sort order here. So I'm going to go ahead and sort the index. But remember, this is returning a new object. So to get it to stick, I need to reassign it to our object here. And there we go. Our data frame is now sorted kind of by the original order since we sorted by the index. So let's talk about data filtering, which is something that you'll do all the time. We have 156 rows here, but let's say that we want to look at just the countries that have a happiness score of greater than 7. How do we do that? Well, to filter the data, the first thing that we're going to do is create what's called we're going to create a Boolean mask. Now, a Boolean mask, this is something that's used in Pandas as well as in NumPy. A Boolean mask is basically just an array of trues and falses. And we're going to have one value per row of our data. So we're going to have, we're going to have 156 of these values. And each value basically says, do we want to keep this row or not? So that's what a Boolean mask is. A Boolean mask is just an array of trues and falses that we can use for filtering. So to create a Boolean mask in Pandas is very easy. So what do we want to do? Well, we want to take a look at our score column. And what did we say? We said that we want only countries that have a score greater than or let's say equal to 7. Now, if we run this, we'll just see what happens. There we go. There is our Boolean mask. So let's go ahead and assign this to a variable, and we'll just call this greater than 7 Boolean mask here. So this is and this is actually a Pandas series that we return there as the Boolean mask. So now to filter our data frame by this mask, all that we have to do is pass this mask in to the square brackets. Very much like when we're looking at a column and we pass the column name into the square brackets. Now we're going to pass our Boolean mask into the square brackets. Let's run this and take a look. And here you go. You see that we now only have 16 rows of data, and all of the scores are greater than 7. So that's how easy it is to filter data in Pandas. And to take it a step further, I'll show you how to filter by multiple conditions. And it's very easy. So to filter by multiple conditions, what you do is just create 2 different Boolean masks and kind of bring them together. You do the and operator to say, like I want this to be true and this to be true. So I want true and true essentially. So let's go ahead and do that. So to filter by multiple conditions, let's just start by getting our first condition here. So the score greater than 7. And let's say that we want our healthy life expectancy. Let's say we want to see if there are any countries where the healthy life expectancy is less than 1 and the happiness score is greater than 7. So we'll take a look at our healthy life expectancy column, and we'll say that we want this to be less than 1. So here you go. You see that we've got kind of 2 Boolean masks, and then to bring them together, we just use the logical and operator with both of these. So I'm going to wrap these in parentheses to keep kind of our order of operations all nice and clean. Let's copy this up here, and let's say and. So we want the score greater than or equal to 7, and so this is going to do the logical and operator with our Boolean masks here. And we want the healthy life expectancy less than 1. Now, let's delete this cell and run this cell. And it looks like we do actually have a few of those countries. So this is our new Boolean mask. Let's call this, what do we want to call this? We want to call this, let's see, greater, well, score over 7, life expectancy less than 1. We'll just call it something like that. And now we'll pass this into our data frame. And here you go. Looks like we have 1, 2, 3, 4, 5, 6 countries that fit this description. So very high happiness score, but slightly lower healthy life expectancy. Not that under 1 is necessarily like low, because of these don't look like they go too much over 1. So, but there you go. That's how easy it is to filter on multiple conditions simultaneously. And by the way, if we want, I can show you that you can just pass this Boolean mask directly in, let's say we do it like this. You can just pass this Boolean mask directly into the square brackets in the data frame and get the exact same result. So this is just a little bit of how do you want to structure your code, Do you want to assign the Boolean mask to a variable first and then use that variable? That might be a little bit cleaner. Or do you want to use it all kind of in one go here? And this doesn't look too bad either, since we've got each condition on its own separate line. But anyways, let's go ahead and move on. So far, we've talked about looking at our data, but very often what we want to do is we want to create new data, or we want to modify data somehow. So one of the most common things that you might want to do is create a new column. And you probably want to create a new column based on some of your existing columns. So let's say that we want to take our score column and do something simple, like multiply it by 10. Well, in Pandas, that's extremely easy. We basically just take our series object and just use it like any other variable, any other numeric variable, and we can just multiply it by 10. And there you go. You see that we return a new series with all of the score values multiplied by 10. Now, if we want to create a new column from this data, then we basically just use the same square bracket column access notation, but we pass in the name of a new column. So in this case, maybe we'll call it score times 10 or something like that. Now, if we do df.head, let's look at our data again. You'll see over here at the very end is our new score times 10 column. Very easy to do. Now, let's say that we want to combine multiple columns. So this doesn't make a ton of sense with this data, but let's just pretend for a minute. Let's say that we want to create a new metric called GDP times generosity or something like that. GDPerosity, or I don't know. So the way that we can do that is very easy. We basically just take our, not our score, let's do our GDP. GDP per capita, and we want to multiply it, let's say by our generosity column. And let's give this a new name. Let's call it generosity DP. This is a bad joke. Should have stopped already. Okay, generosity DP. So GDP. And then if we look at df.head, then there we go. So does this look, let's see, 0.2. Does that look like our generosity? Let's see, 0.15 times our GDP, 1.3. Yeah, I think that looks about right. So to create new columns in Pandas, you could just do normal math with those columns, like add, subtract, multiply, divide, or you can also do math kind of with multiple series together. But very often, you're going to have more complicated functions that you want to do with a column. And so there is this extremely helpful method on a series called map. And if you're familiar with the Python map function, it's very similar. So let's say that we want to take a look at our score. And we want to say that if the score is over 7, that's a high score, and we want to give it a category of high score. So maybe we want to label these. We want to categorize them somehow. So if it's over 7, then that's a high score. If it's under maybe 4, then that's a low score, and everything else can be just a middle score. So we're going to use the .map function here, and or the .map method on this series. And the way that map works is you basically pass it a function that accepts an input and returns an output. So let's define our function first. So I'm going to say this is going to be map score to category. So we want to map a score to a category. So our input is going to be a score. And we're going to say that if that score is greater than or equal to 7, then we want to return high score. If the score is less than, let's just say less than 4, then we want to return low score. And otherwise, we want to return kind of medium score here. So this function accepts a single input, which is our score parameter right here, and returns it has a single return value. I mean, like all, kind of Python functions, single return value here. So we map an input to an output. So let's go ahead and run this cell so that this function becomes available in our namespace in Jupyter Notebooks. And now we just pass this function directly into the map method on our series. So let's go ahead and run this. And here you go. You see that we have now mapped the numeric score values to a string category or a string label. And let's go ahead and let's kind of jump back to something we discussed earlier and run the value counts method on this series and see how many rows of data we have for each one of these categories. And you'll see that we actually have 16 countries for the high score category, 16 countries for the low score category, and the vast majority of them, 124 countries kind of in that medium score category there. So that's how you can do generic, let's see here. So the map function, or the map method rather, on the Pandas series is how you can do kind of any arbitrary logic that you want on your column. And by the way, if we want to assign this back to a column, then maybe we'll call this, score category. And there you go. So we've got these 3 columns here now that we have defined. One last thing before we move on. So, we defined a function explicitly before using the map function. But one thing that you'll see very commonly is to use the Python lambda syntax to pass in an anonymous function directly to the map method itself. So what does that look like? Well, it basically means that you're defining the function kind of like right there, but it doesn't have a name. It's just kind of an anonymous lambda function that you're passing into the map method there. So, let's say that we want to look for countries that start with the letter S, for example. So what we could do is let's take our country or region series. We're going to call the map method. And then this is where we use the lambda syntax here. So we'll say lambda, typically like lambda x is maybe how you would do this. And what we could say is x is going to be a string with our country name. And we say, we want the first letter to equal S. And now since this equals this, that's going to return a Boolean value. Let's go ahead and run this and just show that you get some Booleans here. So this now becomes a Boolean mask that we can pass back in to our data frame. And you see that we have quite a lot of countries that start with the letter S. So it's a very popular letter here. And there you go. So this lambda function, you'll see this a lot where we're doing a quick function, a quick custom calculation, and we're just passing it directly into map using the Python lambda syntax there. All right, we're getting close to the end. You're learning, the 20% of pandas that you're going to use 80% of the time here. So I hope that you're feeling good about yourself, and I hope that you're following along, by the way, and doing this in your own Jupyter notebook. At Project Data Science, we're all about the hands-on, 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 hands-on. We want you coding because that's really how you learn. I can't tell you how many times I've read something or watched a video and just nothing, just all evaporates after like 24 hours or something like that. So hands-on coding, that's the way to learn. Okay, let's talk about group by operations. So the reason why that we use group by operations a lot is because it's very related to the pivot table in Excel. And so Pandas does have pivot table functionality as well, which you can go learn about. It's very related to group bys. But the group by functionality is what we'll be discussing. And it's basically a way to group your data together into different slices and then do some kind of aggregation on those slices. So this makes more sense if we just go through an example. By the way, if you know SQL, this is exactly a SQL group by. And if you don't know SQL, then you should go learn SQL eventually. So let's say that we want to group our countries by the score. So just like the rough score, just the, is the happiness score a 2, a 3, a 4, a 5, a 6, or a 7? So we want to round these values, and then we want to group our countries by score. And then for each group by score, we want to look at the average GDP per capita. So let's break this down into multiple parts. So first off, we're going to be looking at our score column here, and we want to look at our rounded score. So let's go ahead and call the round method on our series. And you'll see that some of these values do get rounded up to 8 because they are over 7.5. Now, really quick, I'll just look at the value counts again, just to show us how many rows of data we have per category. So it looks like 6 is the most common, followed by 5, and then 4 and 7 are a little less common, and then our happiness scores of 8 and 3 are the least common here. So this is kind of the distribution of our data, which, if you remember, matches the distribution of our histogram that we looked at earlier. This is basically giving us the same information as our histogram from earlier. So we want to round this, and let's go ahead and assign this to, I'll call it score rounded, to a new column. And now what we want to do is we want to group our data by this rounded score. So what we can do is we can call it df.groupBy. And we're going to tell Pandas that we want to group by this new column. So let's just go ahead and run this, see what happens. So you'll see that it doesn't print out anything. And this is, or it doesn't print out anything really useful. And this is because this first part of the group by operation is just taking our data and splitting it up into those groups. And now we need to tell Pandas, like, okay, you know, we've got these groups, but what do we want to do with each group? And just to show you that, that this is splitting the data up into groups, let's assign this group by object to a variable called GB. Let's look at our methods and attributes on GB. So we have a groups attribute here. Let's look at that. And what you'll see is basically a dictionary where the key is the rounded score. So here's our rounded score of 3, rounded score of 4, rounded score of 5, etc. And then the value for each key is the list of the indices where that score occurs. So this is maybe easiest to see if you look down at our key 8 here. So 8 means that the rounded happiness score was above a 7.5. So these were our top happiest countries. And you'll notice that the indices here are 0, 1, and 2. So these tell us that these were the top rows in our data frame. And if we scroll back up, you know, you'll see that Finland, Denmark, and Norway have indices of 0, 1, and 2. And the score is indeed above 7.5. So it gets rounded up to 8. So this GB.groups tells us how Pandas is splitting up the data. But you know, usually you don't have to worry about this. I just kind of wanted to show you what's happening under the hood here. So typically what we're going to do is we're going to take our group by object and we're going to call some kind of aggregation method on it. And so, you know, basically the idea is we group our data and then we've got a bunch of little groups, and then we want to find a way to aggregate the information in each one of those groups. So we need to call some kind of aggregation function on it. So let's look at the mean. So here you go. You see that we have grouped our data by these rounded scores. We call .mean, and this is going to take the average of all of the data in that group for each column. So this is maybe easiest to see with the score column here. You'll see that the average score for all the countries in the group where the rounded score is 3, the average score is 3.27. And then the average score for the next group is kind of 4.17. This is interesting. So the average score for all of the countries in the 5 group is slightly less than 5. And this is because, you know, you remember that a score value of 4.5 is going to get rounded up. So, but really what we want to look at here, we didn't want to see the averages for all of our columns. We wanted to see just the GDP per capita. So let's just zoom in to this column of our results here. And here you go. You see that the GDP per capita value, and what, you know, once again, we're not entirely sure what these units are, but the GDP per capita is low for the for the countries with the low happiness score. And then it gets higher with each increase in kind of the happiness score here. So this shows that there is that positive correlation between a country's GDP per capita and a country's happiness score. So that's good information to know. Okay, so we're almost right at the end here. The last thing we want to do is we've done some work, we've created some columns. If we had dirty data, then maybe we would have done some data cleaning. Now we want to save our data back out to a file, or maybe we filtered it somehow, But either way, we've done some work with our data. We want to save it back out to a file. So this is going to be just as easy as loading the data. Rather than read CSV, we're going to call this toCSV function here. So toCSV, so we'll give it a file, and let's call it 2019 enriched.csv. And it's enriched because we've added some columns. And then we're going to pass this one extra parameter here, index equals false. So Pandas by default writes your index out to the file as well, because you might have useful information there. We don't really have useful information in our index currently, so we're just going to call index equals false. So let's go ahead and run this. That runs successfully. Let's come back over here. Let's hit enter a couple times and run ls. You'll see here's our 2019 enriched.csv. So let's go ahead and open that. Open 2019 enriched. And where is it going to pop up? Here we go. Here's our CSV file. So not only do we have all of our original columns, but you'll see over here that we actually we have these new columns as well. So we've got our score times 10, our generosity times our GDP, our score categories, and our score rounded. And with that, we have come to the end. So there's obviously a ton more to learn with Pandas, but this is the 20% of Pandas that you need to know to get 80% of the value right away. And using just the things that we've gone over in this video, you should be able to do a lot of what you want to do in Pandas. And if there's other things that you want to learn how to do in Pandas, then, Google around, learn it, look through some of the other project data science resources. But hopefully this is enough to get you up and running very quickly. So thank you again for watching. Good luck on your data science journey. Happy learning. Click subscribe if you want to see more videos, and we'll see you later.